So in this video, I wanted to talk about interpreting the p-value. That's usually one of the more challenging things for students to do, is to understand what that means. So when you run any of the hypothesis tests, you always get a p-value. And we compare that p-value to the significance level, and that determines whether we reject or fail to reject our null hypothesis. But what we want to think about is, like, what does this p-value really mean? Like, what does that value mean that we're getting in these tests? And so the definition of the p-value is it's the probability of getting the results from the sample or more extreme than the results from that sample, given the null is true. So a very important thing is when we're running a hypothesis test, the tests are always assuming that the null is true, which is why our null hypothesis is always like the equal sign in it, because we're assuming it's equal to a certain statistic value, or the two samples are equal, and we're assuming that's true, and then we're testing our data against that assumption that that is always true. So for an example, say I ran a 2-prop z-test, and the hypothesis test produced a p-value of 0.023. And it says, give a statement that defines the p-value. So the first thing you have to think about, okay, what does the null and the alternative look like when I do a 2-prop z-test? And when we do a 2-prop z-test, we're comparing two proportions, and our null is always like P1 equals P2. So we're always assuming that they're equal. And then our alternative is that either P1 is greater than P2, P1 does not equal to P2, or P2 is less than P1. And they didn't tell me which is my alternative, so I can't explain it in that terms. But what this p-value is saying is it's the probability of getting whatever results I did from my sample, assuming that this null is true, that P1 equals P2. And so the smaller the probability is, the less likely that the sample results could have happened by chance. And that's why we reject the null, because it's a good chance that the null is false, because our p-value is saying that the probability of this happening, assuming the null is true, is really small. And so it probably wouldn't have happened by chance. Versus if my p-value is larger, then there is a good chance of getting the sample results when our null is true, and that supports the null hypothesis, and that's why we fail to reject it. So if I'm interpreting this, what I'm saying is that this 0.023 is the probability of getting the results from this sample or more extreme, given that the null is true. So in this case, again, I don't have the sample, so I'm going to use this wording. I would say something like there's a 2.3% chance, or there's a 2.3% probability that the difference between the sample proportions is more extreme than what was observed, and that's the data we're collecting, given that P1 equals P2. And that's because that would always be my null if I'm doing a 2-prop z-test. So please make sure that you're always including given that whatever the null is true, because that is part of the definition of a p-value. And then also saying that it's the probability of getting the results of the sample or more extreme than our sample, right? And that's how we interpret the p-value. Okay, so just for one more with interpreting the p-value, this is from the Unit 3 packet. This is a new reading program may reduce the number of elementary school students who read below grade level. A company that developed this program sampled materials, and the teacher training for a large-scale test involved nearly 8,500 children in several different school districts. Statistical analysis of the results showed that the percentage of students who did not meet the grade level was reduced from 15.9% to 15.1%. Okay, so this is the results of our sample. The null hypothesis is that the new reading program produced no improvement was rejected with a p-value of 0.023. So this problem is talking about one sample. They sampled 8,500 children, and they compared the percentage of students who did not meet grade level with like a national standard. So I'm comparing proportions. And so this, and because I have one sample, this would be an example of a one prop z-test. And if I was thinking about it, my null would be originally what it was. So the null would have been, no, sorry, I should be doing P because it's a prop z-test. The null would have been that it was 15.9%. Or again, I should usually write that as a decimal. So 0.159. And the alternative was that it was reduced. So the alternative in this case was P is less than. I need a little more space, so we'll put it up here. So the null is P is equal to 15.9%, or P equals 0.159. And the alternative is that it was reduced. So P is less than 15.9%. Or P is less than 0.159. Okay, so those would be my null and my alternative. So if I want to explain what the p-value means, and again, it's this is my p-value, we would say this is the probability of getting the results of this sample or more extreme. So it's the probability of the test scores being reduced to 15.1% or lower, given that the original percentage of students who did not meet grade level is 15.9%. So this would be the probability of it being reduced, again, given that the initial proportion is 15.9%. So one way to write it is there's a 2.3% chance of getting results that are more extreme than the sample, given that the percentage of students who did not meet grade level was 15.9%. And so this is another way of interpreting that p-value. And this time we're doing it for a one proportion z-test versus a two sample proportion test. So please let me know if you have any questions about that. Again, make sure you know how to explain the p-net value and the definition.